Problem 5 says determine the critical numbers of the function f of x equals x ln of x. So now we have no graph, no picture to look at, and we want to determine how do we do this algebraically. So the first thing that you need to do is you've got to do a domain check on the function itself. So x will accept any value, but ln of x can only accept positive numbers. So the domain of f is 0 not included to infinity. So I have to make sure that when I'm saying the derivative doesn't exist, or that the derivative function won't accept a certain number, if that number was never in the domain to begin with, it's not truly a critical value. So we find the critical values by first calculating the derivative of this function. So this is going to require a product rule. The first function of x, and the derivative of that is 1, times the second function, which is ln of x, plus x times the derivative of 1 over x. This simplifies to ln of x plus 1, because these two x's cancel. So I need to see where the first derivative equals 0. So we need to solve this for x. So I'm going to subtract 1 from both sides. And then to get ln x out from the natural log function, I'm going to use its inverse. So I'm going to plug both sides into e to the x. So e to the negative 1 equals x. Well, e to the negative 1 is the same thing as saying 1 over e. 1 over e is a positive value that's bigger than 0, so it is in the domain. So my critical value is 1 over e. I also need to check where the derivative might not exist. So if I go back and I look at this function, well, the only values of x that wouldn't work in this equation are values that are negative or 0. But if we look at the domain of the original function, it didn't take anything that was negative or 0. So there are no more critical values. So this is our only critical value.